Hi, I am Om. Today in this video, I am trying to explain you what is an execution context in JavaScript and how execution context work inside the JavaScript. So first of all, let's understand this concept that everything happens in JavaScript happens inside an execution context. Right? So now we will see what is execution context and how it works. So basically, you can understand execution context as a box or a container. Right? So this is our execution context. So basically, in execution context, there are two phases. First phase is memory phase, and second phase is code phase. Let me draw this. Okay. So the first phase is memory phase, and the second phase is code phase. Now, what is memory phase? So basically, inside the memory phase, JavaScript assigns the values to all the variables and functions. This happens inside the memory phase, right? Well, let's say we have a variable, and one more thing. It stores the values as a key value pair, right? In the form of key value pair. So key value pair. Right. For example, if you are declaring a variable a inside the JavaScript and we are assigning the value 7 to it, right? So it will looks like this. And in the case of function, JavaScript stores the complete function inside this memory phase, inside this memory space, right? So what happens here is inside this memory phase, JavaScript stored everything as a key value pair. So we have assigned the value of 7 to this a, and the value of function here is a complete function, is the complete code which we wrote inside this function. Right. Now inside the code phase, what happens is JavaScript executed the code line by line. First this line will execute it, then this line will execute, then this line will execute. So everything will execute in an order. So now the first thing which we have to remember that JavaScript is a single threaded JavaScript JavaScript is a single threaded synchronous language. Wait, what does it means? So when we say JavaScript is a single threaded synchronous language, it means that first of all, single threaded and synchronous, these both are two different terms, right? So what is meant by single threaded? Single threaded means the code is executed one command at a time. It will execute one command at a time. Firstly this command will execute, then this command will execute, then this command will execute. This is called as the single threaded. And what is meant by synchronous? Synchronous means everything will execute in an order. Everything will be execute in an order. First this line will execute, then this line will execute, then this line will execute. So this is why we call JavaScript is a single threaded synchronous language. And now this whole box is called as execution context. It's that easy. So now let's see like how JavaScript code is executed inside an execution context. So first of all, let's say we have this example with us. So now let's create an execution context and see how the code is being executed. So this is our execution context, and as we know there are two phases in the execution context. First one is the memory phase and second one is the code phase. So let's create that. So this is the memory phase, and here we have our code phase. Now what happens inside the memory phase is that when the JavaScript engine will encounter this first line where n is equals to 2. So here we have declared the variable n. So what JavaScript will do, it will assign the memory to this variable n. So here JavaScript will assign the memory to n. But wait, what? JavaScript will not directly assign 2 to this variable. Firstly, JavaScript will assign undefined value to this variable. Now what happens when JavaScript will encounter the second line of this code? what we have said earlier is that it will take this complete function and put it as a value inside the memory phase. So now here we have the function name addition, and the value for this will be this complete code. Value for addition will be that complete code. Now let's understand. After that, the JavaScript engine will encounter this line where add2 is another variable. So now what we can do here is add2, and again this will be undefined. Now add4, similarly add4, and it will also be undefined. Now what will happen? This is our first phase of our execution, right? Now when we will move to the second phase of execution, which is the code phase, now what will happen? JavaScript will see that the value of n is 2 here. So what JavaScript will do, it will delete this value, and put the value of n as 2, right? Now what will happen when we will go inside this function? There is nothing to do. Now we will come to the second line. So JavaScript will do nothing here because there is nothing to do with this function, right? When we will go to this line, now here comes an interesting part. JavaScript invokes this function. We invokes this function, which is addition. So now when we invoke a function, all new execution context is created again. So let's create an execution context again here. So again we will have two phases. First one is memory phase, second one is code phase. Now inside this, what we can do, now as this function is called, so inside this function we have two variables, right? First one is num and second one is answer, right? So let's take num. It will assign as undefined in the first phase, and answer will also define as defined. Will also be considered as undefined, right? Now we'll come to the second phase, where as we know, num, it is the parameter of this function. So here, as you can see, here is n, which is coming from this. So now JavaScript knows that the value of num is 2. JavaScript knows that the value of n is 2. And again, now the answer, what this answer is saying, num plus num, which means 2 plus 2. We are doing here 2 plus 2, right? The logic will execute here 2 plus 2, and we'll get an output of 4. Now the value of answer is 4, and now what JavaScript will do is it will assign this value to this ANS. Now this is no more undefined, and we'll get 4 here, right? So as we get 4 here, now what JavaScript will do is the value of ANS is 4, right? And we have returned ANS, right? So what this function returns here is 4. So the control will go to outside this block, and the value of add2 will be 4 now. The value of add2 will be 4 now. As the value of add2 is 4 now this execution context will be deleted, right? So now this execution context will be deleted. Now when we go to the another line where add4 is equal to addition 4, here once again we invoke the function. So what will happen? Again, an execution context will be created. Again we'll have two different phases. First one is memory, second one is code, and the same process will happen once again, right? So we'll go to the ANS. Firstly we will have num as a parameter. So here is num, and it is undefined for first phase, right? And after that we will get to ANS. That will also be undefined in the first phase. Now when we go to the second phase, what we can see is that here num is 4. see, this is the parameter, this 4 is going here inside the value of num. So now what will happen, the value of num will be 4, right? And this operation will get performed like num plus num. So what will happen here is 4 plus 4, which is equals to 8, and this 8 value will be stored in ANS. So now again, answer is also no more undefined, and the value of NS is 8 now. Now this ANS 8, again we encountered a return statement, so it will send the control outside this block. So now the value of ANS is 8, and this ANS 8 will be the value of this add 4, right? This is the value of add 4, 8. Now we have all the values present inside this memory phase, and we'll get our answer. But now, as we saw that lot of execution contexts are getting created and lot of them are also getting deleted. So how JavaScript handle all this mess? So let's understand this. So for this, what JavaScript uses is called as stack. So what is stack? So basically it's like this. At the bottom there is a global execution context. Which was created at the first time when the code starts executing, right? After that, when the function gets invoked, then the new execution context started to create on top of this global execution context. So let's give it a name as a f1, for example. So this is for function 1, f2, this is for function 2, right? So when this function 2's execution context will get executed completely, this execution context will get deleted. After that, this execution context will be deleted, and at the end, when we get our original output, the global execution context also get deleted, and we get our final output.